Hello students, welcome to Vista's Learning. I am Harshitha, your chemistry tutor at Vista's Learning. So why you need to watch Vista's Learning? Vista's Learning is an online education platform where we strive to provide quality education for all. So through our videos, you can see a lot of chapter videos which has much more clarity on each and every topic. So we are not giving a summary of an entire chapter. Through our videos, we are explaining each and every topic in a detailed manner along with solving the exemplar problems as well as the exercise problems, right? So we are starting with our fifth chapter from your class 12 chemistry, that is surface chemistry. What are we going to learn in surface chemistry chapter, or what exactly is surface chemistry? So this is a branch of chemistry where we deal with the surface phenomena, as in any of the reactions which is happening on the surface. So such kind of reactions which happen on the surface of any object, we call it as surface chemistry. So we will be dealing with all of those kind of reactions, the phenomena which take place on the surface. So that is what comprises of surface chemistry. So without any further delay, we will just see what are the different topics that we are going to be studying and the basics that we are going to learn in today's session. Firstly, we will be seeing the two surface phenomena, that would be absorption and adsorption. You must have heard this a lot of time in your previous classes as well as you are studying. You must be aware of what exactly is absorption, but not that much aware of what exactly is adsorption, right? So we will be understanding what are these two phenomena, as well as we will compare both of these phenomena as well. Basically, in absorption and adsorption, we will see the mechanism of adsorption in specific. So why exactly adsorption is taking place and how exactly adsorption is going to be useful for any of the reactions that is happening on the surface. So we will understand that in mechanism of adsorption, as well as we will learn about the thermodynamics of adsorption as well, as in how much heat is being released or why exactly heat is being released. All of these things we will understand in thermodynamics of adsorption. And we will see differences between absorption and adsorption. So that will be the last, as in we saw what exactly is absorption and what exactly is adsorption. So when we compare both of these, how can we understand both of these in an easier manner? We can understand that by these differences. And it is an important question as well from this particular chapter. So the differences between absorption and adsorption, or they might even ask like, this is the thing that is happening in absorption. What exactly is happening in adsorption? Or why exactly is it different in adsorption? So something like that, reasoning type of questions can come from this chapter and basically from this particular topic. So we will see firstly the introduction of surface chemistry. Okay, so what exactly is surface chemistry? As I told you, it deals with the phenomena that happens on the surface of or the interface. So on the surface of any substance, the phenomena which takes place, that is known as surface chemistry. Any kind of phenomena that takes place on the surface or interface. Now, what exactly is an interface? We'll understand that by this particular diagram here. So we have a beaker and this beaker has liquid in it. Okay. And above this liquid, there is another substance which is present. There is gas molecules which are present. So this will be another substance which is just present above the liquid, which will be gas. Now, on the surface of the liquid, this part, the gas molecules come and accumulate. Okay, so the interaction that happens between this layer and this layer, this is known as interface. So this particular region, the surface, is known as interface. So any kind of reaction that happens on the interface is known as surface chemistry. That is what we deal in surface chemistry. Clear? So we can write this basically as the interface can be written as liquid or gas interface, right? Liquid gas interface, either with a hyphen in between, or it can be written this way. Liquid gas interface, okay, a slash in between. This is how we can represent the interface. Now, this is in liquid and gas. The same way liquid and solid also we can see. But when it comes to two gas molecules, as in a beaker, we can see there's one layer, there is one gas molecule to which there will be another gas molecule which will be introduced, okay. Another set of gas molecules will be introduced into this beaker. Can we see an interface between these two gas molecules? Can you all think about it? Is it possible to see the interface, the layer between both the two different types of gas molecules? No, right? Why? Because the gas molecules basically have the spaces between them. So if I'm taking okay, the plane will be, okay, the one which is not being colored would be one set of gas molecules, whereas the other one which is a little colored is another set of gas molecules. So I'll take this as 1 and I'll take this as 2. So when I introduce 2, the gas molecules, this different set of gas molecules, that is 2, into the layer of 1, they are going to be a lot of spaces between this 1, okay, through which the second gas molecule can enter. There's going to be a lot of miscibility between both of these gas molecules, and that is the reason we cannot see any kind of interface between the gas molecules. So there cannot be any there cannot be any kind of interface or surface phenomena which can take place between two gas molecules. Okay, so this is exactly seen with liquid, gas, solid, liquid. Only these kind of states we can see this kind of surface chemistry, as in surface phenomena. Clear? So I hope you have understood what exactly is the surface chemistry. Now we will go into the surface phenomena which will be which will be happening in the surface chemistry. Basic phenomena, that is going to be absorption and adsorption. Okay, so before we get into that, we will see what exactly is this adsorption basically. So here you can see there is a beaker. Okay, so this beaker has liquid molecules in them. This liquid molecules, whatever is going to be, this yellow color liquid molecules, they are surrounded by other liquid molecules, as in the same liquid molecules which is there around them, and they are going to pull these liquid molecules from all the directions, because in all of these directions there are different liquid molecules which will start pulling them, and it is going to be balanced. Okay, they are pulled because of the attractive forces between them, and they are going to be balanced, whereas this is in the bulk. Okay, in the bulk this is what happens, but when we come to the surface, it is going to be a little changed. How is it going to be changed on the surface? That is because in the surface, you can see above there are no kind of liquid molecules. Only below and around this side there are liquid molecules. So these liquid molecules which are there on the sides are only going to pull the liquid molecule on the surface. Above whatever it is there, nothing is there, right? So there is no attractive force which is found above. So this is going to be very unstable. Unstable as in it has a lot of energy in them. It is not stable at all. So when there is a lot of energy which is present and it is unstable, and we can find here a very unbalanced attractive force also. So because of this, there is an inward pull which is happening inside. So that creates a tension on the surface. Okay. So when the tension is being created on the surface, that is when adsorption usually takes place in order to balance the state. In order to balance the state of the surface molecules. This tension created on the surface is known as surface tension. Clear? In order to avoid the surface tension, we will see the adsorption process happening. Clear, students? I hope this diagram is made you all understand why exactly adsorption is taking place and how exactly adsorption is seen in the surface, as in the bulk as well as on the surface. Okay, in bulk, how the molecules are present, how the stability is found, how there are very stable and balanced attractive forces between, whereas when you see on the surface, you can see there is unbalanced attractive forces which are present, and it is highly unstable. So it is striving to become stable. Clear? So as I told, now we understood what is adsorption and adsorption basically, and why exactly it is happening. Now we will see the process absorption. So what is absorption? You all know that very well. So we know when we dip our clothes in water, okay, it becomes heavy and the entire cloth becomes wet. That is nothing but absorption. There is uniform distribution of one molecule into another. That is what is absorption. We can understand this by another experiment, basic experiment. So we take a bowl or we take a beaker which has water in it, and I'm going to take a sponge. Okay. So and then I'm going to dip the sponge into this beaker of water. After I dip it, after a while, you can see the sponge actually becomes bigger. It becomes heavier, right? So how exactly it becomes heavier and bigger? That is because the pores which are present in the sponge is going to get all the water which is present in the beaker. Fine. And it becomes heavier and it is spread out uniformly on the entire surface, as in not just the surface, entirely uniformly distributed inside the sponge as well. This particular phenomena is known as absorption. So one substance enters and distributes uniformly throughout the bulk. Such a phenomena is known as absorption. It distributes uniformly inside the entire bulk. This is what is absorption. You can see a lot more examples like wet paper, okay, when we put a paper into the water, tissue paper into the water, chalk in water, all of these are examples of absorption, where water, basically here, water is going to be distributing itself uniformly in the entire chalk or the paper. Clear? So now when the absorption is taking place, there are two different substances which are there. How we can relate these two different substances? Like we saw in solution. We studied the solution chapter, right? So going back to the solution chapter, we saw there is solute and solvent, right? So what exactly was a solute? The substance which is there in a small amount, okay? And what exactly is a solvent? The substance which is there in a large amount, okay? When the solute is put into the solvent, the solute distributes itself throughout the solvent. That is solute and solvent. Together it forms a solution. The same way here in absorption process, there is absorbate as well as absorbent. Okay. So we will see what exactly is absorbate and how can we relate it to solution and as well as absorbent. The substance which is being absorbed is known as absorbate. Okay. The substance, what is going to be absorbed here? The chalk that is going to be absorbed here. That is going to be the absorbate as well as the substance which absorbs. Okay. Sorry. This is going to be water basically, and this is going to be chalk. Okay. So the substance which absorbs the water is going to be absorbent. Okay. Which is nothing but we can relate it to solute and solvent, as well as the substance which is being absorbed. What is being absorbed here? Water is being absorbed here. That is known as absorbate. Okay. The same kind of phenomena we see in adsorption. It's just the process is different. So we'll see what is adsorption. Adsorption also is nothing but the accumulation of the molecular species at the surface rather than entering into the bulk. Okay. Just like our powder, you can see. Okay. We apply powder, we apply makeup on our faces and all, right? So when we put a powder or makeup on our faces or lipstick or anything, any cosmetic on our faces, it is not entering inside our face and entering into our body, right? It is just on our surface. So once we wipe it and clean it off, it's just going to go away, right? So that is a basic example of adsorption, simply relating to our day-to-day life. So writing the chalk, we take the chalk and write it on the board, right? So the chalk powder is not entering into the board. It is right there on the surface itself. So such kind of phenomena where the accumulation of one species on the other is known as adsorption. Simple as such. Okay. So example would be silica gel. Another example which we see daily is silica gel. So you can see when there is new shoe bought or new bag if we bring, there will be this silica gel packets which are there in all of these. Why exactly is it present? This silica gel basically is going to absorb all the moisture which is present around on the surface. It's going to absorb itself. Okay. So that is the basic function of silica gel. It is just going to accumulate all the moisture. It's going to absorb the moisture, and that moisture is going to be present only on the surface of the silica gel. So this is also one of the basic example of adsorption. Here also, as I told, the substance which is being adsorbed, okay, that is going to be adsorbate, as well as the substance which is going to be adsorbed, okay, which absorbs itself. Okay, the substance which absorbs is going to be adsorbent. Okay, we can relate it to, as I told, solute and solvent. Simply relating it to solute and solvent can even get you all an idea of how exactly we can interrelate both of these and understand in a simpler way. Otherwise, it will be like a new term we are learning, nothing like that. So already what we have studied, if you can relate it to this, it will be easier for you all to remember as well. Okay, you can recall easily. Clear, students? So we understood what is adsorption and what is absorption. Now we will see the forces. Okay, as I told, the forces which are acting between them, that also we just saw. Which are the forces that acted between them? The attractive forces were the ones which acted between them. Where in the bulk we saw the forces which are acting was balanced attractive forces, whereas on the surface we saw unbalanced attractive forces that was acting on the surface molecules, which created the surface tension. Now there are two terms which you all have to understand along with this absorption and adsorption. Okay, basically with respect to adsorption, that is known as desorption and sorption. So what exactly is desorption? Desorption is nothing but removal of the accumulation of the species, whatever was happening on the surface, right? The adsorbed species on the surface, whatever was there, removal of those species is known as desorption. And what exactly is sorption? Sorption is nothing but where adsorption also takes place, at the same time desorption also will take place. Both of these phenomena takes place simultaneously. That is known as sorption. So to understand it in a much more better way, we'll see it through a diagram. So here there is the same case beaker which is having a liquid in it. So this is the liquid molecules which are present in the bulk. You know, in the bulk the liquid molecules distributes itself uniformly. If I put any other substance on the surface, right, that is absorption. Now we are talking about what? We are talking about adsorption only. So what did I tell about desorption? Desorption is nothing but removal of the adsorbed species from the surface. So here you can see there is adsorbed species on the surface. Sorry. So this species is being adsorbed on the surface of the liquid. Now removal of this particular liquid, okay, removal of this particular liquid is known as desorption. Okay, this is being removed. This is desorption. As this was being removed, there was one more species which was being adsorbed on the surface. Can you all see that? As this was being removed, simultaneously there was one more species which was being adsorbed on the surface. So such kind of phenomena where both these takes place simultaneously is known as sorption. Clear, students? So this is a basic phenomena what we have to understand with respect to adsorption, that is desorption and sorption. Important question, they can ask you for a 1 marker, or they can ask you for defining both of these and give examples. That way they can ask this particular question. Now the same definition as I explained before. The process of removing an adsorbed substance from the surface is known as desorption. And what is sorption? When adsorption and desorption takes place simultaneously, we call this phenomena, or we call this process as sorption. Now we'll come to the mechanism of adsorption. So we saw how exactly adsorption is taking place, what exactly is adsorption, and the two basic phenomena, what happens in adsorption also we saw, that is desorption and sorption, along with the examples. All of these basic things we understood. Now we will get into the mechanism of adsorption. Why exactly adsorption is taking place, and why is it important for the adsorption to take place? Okay, so we saw in the surface, in the beaker, as we saw, there is bulk. Okay, there is a bulk substance which is present, that's the liquid. So in the bulk, the liquid which is present, it is being pulled by it is being surrounded by other liquid molecules, and because of the attractive forces between them, the other molecules, liquid molecules are going to pull them together. Okay, so hence it remains in a stable format, the liquid molecules which is there in the bulk. But when we come to surface, what happens? When we come to surface, this molecules which are there around are only few. Okay, it's not being surrounded entirely. So since it is not being surrounded entirely, what can we tell here? We can tell here there is an unbalanced attractive forces. Okay, unbalanced attractive forces are only present, and only those are pulling this liquid molecules which is there on the surface, because of which there is an inward pull happening. Because of the inward pull, there is a tension which is created. Since there is a tension which is created, the molecule is very unstable in state, and this tension is known as surface tension. Okay, so in order to make sure that this surface tension is not going to take place when any other molecule is going to come in contact with this. Okay, so when there is any other molecule which comes into contact with this, it gets adsorbed on the surface of this molecule. Once this other molecule, which is going to come and get adsorbed on the surface of this molecule, here we can see there will be different molecules which adsorbs, right? On the above surface also, there is another molecule which is going to start pulling the surface molecule. So what is happening here? Now what was unbalanced will become balanced, okay? Which was unstable will start becoming stable, and it will give out a little amount of heat as well, okay? You know, right? When there's unstable, like when the molecule is unstable, it is being highly reactive, and it wants to react very soon, and it wants to become stable by any chance. So in the process of becoming stable by any chance, it's going to give certain amount of heat. So that is the reason we call this even as an exothermic process. So exothermic process, why? Because certain amount of heat is being released. Clear? So here you can see this is the mechanism of adsorption, and this is the main reason why adsorption is taking place. To make sure that the surface molecules are going to be stable, and there's going to be no kind of surface tension which is being created on the surface. Clear? Now we will, whatever I explained you right now, we'll just see in the terms of sentences, okay? That will make sure, that can give you all notes also to write down, and it can make you all understand also in a better way. So what we saw basically in the bulk, the molecule in the bulk is balanced attractive forces. It has balanced attractive forces because it is being surrounded by different molecules around them. Different molecules, as in the same molecules, are being surrounded around them, which is going to pull them in every way, and the balanced attractive forces are being produced. So hence the molecule in the bulk is stable, okay? But when we see the molecule in the surface, it's unbalanced. Unbalanced attractive forces are present. The molecules which pull them are going to be only in the side, it's not pulling them from top. So hence this molecule on the surface is going to be unstable in nature. But this is the starting, before adsorption is taking place. Once the adsorption takes place, what happens? Okay, same thing before adsorption. Unbalanced attractive forces, unstable, and more energy. It's highly reactive, a lot of energy it has. Once adsorption is taken place, we can see this is in the surface. So balanced attractive forces are going to be present, as in the molecule is going to be present on top as well. And the entire molecule, the surface molecule, is going to become stable, because right now it has all the other, every other molecule on the sides which are pulling them together, providing them attractive forces and keeping it insane, okay? So hence it is going to become stable and less energy. How does it become from more energy to less energy? Because it gives out a little amount of energy, okay? And it becomes stable. So this is basically the mechanism of adsorption, and why exactly adsorption is taking place. I hope you all have understood, because usually with mechanism only we will understand why exactly is the adsorption taking place, or what is the importance of adsorption. Okay, because when I told you what exactly is absorption and adsorption, you all just understood the process. Okay, this is adsorption, this is absorption. But why is it necessary? We can understand this only by this mechanism. So I hope you all have understood what exactly is adsorption. Now we'll get into the thermodynamics of adsorption. I told you certain amount of heat is actually being released, right? So it is an exothermic process basically. It's an exothermic process. So during adsorption, there is always a decrease in the residual forces. So when adsorption is taking place, the surface energy is going to be occupied, right? So once the surface area is being occupied, surface energy is going to be utilized, right? That is the reason there is a decrease in the residual forces on the surface. There is a decrease in the surface energy also, which appears as heat, which is given out in the form of heat. That is the reason we can see delta S is going to be negative. Okay, so basically the Gibbs free energy, what is there? Okay, Gibbs free energy is supposed to be negative. Okay, why exactly Gibbs free energy is supposed to be negative? That is because this is the Gibbs free energy formula. I'm sorry. This is the Gibbs free energy formula. Now, this Gibbs free energy is supposed to be negative to make sure this adsorption process is spontaneous, so that we don't have to provide any kind of energy basically for the adsorption to take place. How can we make this Gibbs free energy negative when we make the entire process spontaneous in nature? So we saw delta S is actually going to be negative here. Okay. What exactly is delta S? It's the entropy. Okay. Entropy means what? It's the randomness. Okay. The measure of randomness. So before we can see, before the adsorption takes place, the gas molecules are just on the surface of the liquid are just random in nature. Okay. So they're just moving around, as well as the surface molecules also are being pulled inward. The randomness of the gas molecules on the surface of the liquid is quite high before adsorption will take place. But as the adsorption process takes place further, you can see the randomness decreases because these gas molecules will come and accumulate on the surface of the liquid. So once this randomness actually decreases, we can see delta S as negative in nature. So once the delta S is negative here, right? Once this delta S is negative in nature, you can see this negative and negative becomes positive. We basically want delta G to be negative. In order to make sure delta G is negative, even this, okay, this should be less negative and this should be more negative. Okay, this entire thing should be less negative. The randomness should reduce more and more, and this should be more negative. That is the heat which is released. Okay, so delta H should be more negative and delta T, delta S, this entire thing should be less negative. That is when we can make this delta G negative, which finally makes the entire Gibbs energy process spontaneous in nature. So we saw how exactly delta S is negative in nature. Now we should see how exactly delta G is going to play a role. So for the process to be spontaneous, the thermodynamic requirement is that at constant temperature is going to remain constant and the pressure is also going to remain constant. Delta G is supposed to be negative, whatever we saw right now. So here delta H basically is going to be more negative. How can we tell that? Once the randomness decreases, once the unstable molecule which is there on the surface becomes stable, it is going to lose a lot of energy. Okay, once we make sure it loses a lot of energy, we can make sure delta H is going to be negative. So once the delta H becomes more and more negative, we can finally tell that delta G is negative, and this Gibbs free energy is going to tell us the reaction is spontaneous. Adsorption process is spontaneous. Spontaneous in nature. Simple. So this entire thing was exactly the thermodynamics. Basically the thermodynamics of this entire adsorption process. So what did we learn till now? We learned what exactly is absorption, right? So what is adsorption also we learned along with a few examples. We just saw the definition. So after that we saw the entire mechanism, okay, the forces which act between these molecules in the bulk as well as molecule in the surface, that is with respect to adsorption. We saw that. After that we saw in a detailed manner why exactly this adsorption is taking place. Okay, so what is this adsorption and what are the phenomena in adsorption, that is desorption and sorption. We saw that, as well as we saw the mechanism of adsorption. Why is it necessary for adsorption to take place? After that we saw the thermodynamics of adsorption. So we knew certain amount of heat is actually released. Why is that heat released? That is because the reaction is exothermic in nature. When the surface molecule becomes unstable to stable, okay, yeah, it turns out to be from unstable state to stable state, it will have a lot of reactivity and energy. It's going to give out that energy, right? So it becomes stable. That is the reason this heat is being released. And that is the reason we can call this entire thing as an exothermic process as well. So we understood that as well. And now we are going to be seeing the differences. Okay, so the differences between absorption and adsorption. As I told, it's an important question as well. So right now you will have an entire recall of what we studied in today's class. Okay. So firstly, absorption is a bulk phenomena, correct? So when one substance is introduced into the other substance, this substance one is going to distribute itself uniformly in the bulk. Okay, so hence we can call absorption as a surface phenomena. When it comes, bulk phenomena. But when it comes to adsorption, it's a surface phenomena. How is it so? That is because when the adsorption is taking place, adsorption basically is a surface phenomena, right? There are substances which are going to come and accumulate on the surface of the liquid or solid or gas, anything, sorry, not gas, basically liquid or solid, okay? So when the substance 1 is going to come and accumulate on the surface of substance 2, that kind of phenomena is known as surface phenomena, and that is only seen in adsorption. Absorption is having uniform distribution. So one molecule distributes uniformly in the molecule or in the bulk of substance 2. Okay, that is absorption. We saw the sponge, right? Now adsorption. In adsorption, what is it? It's a non-uniform distribution. So on the surface of liquid, we can see only gas molecules come and accumulate only on the surface. It doesn't enter inside. So it is a non-uniform distribution in adsorption. Absorption is neither exothermic nor endothermic. Okay, in absorption process, we can neither see heat releasing or it requires heat to take. Okay, basically like a solution formation, right? Certain solution formation or certain absorption process, we can see a little amount of heat can be released, but generally if we are seeing, it's neither exothermic nor endothermic. But when we see adsorption, it's exothermic in nature. We saw the heat is being released when the adsorption process is taking place. You know, when the molecule on the surface tries to become stable, whatever high energy it has, it releases in the form of heat. That is known as exothermic in nature. Absorption, in basically absorption, the rate of absorption is uniform. We can calculate the rate of absorption, it's very uniform. Mixing sugar and water, right? It's solution formation, whatever we saw. So once we mix it, we can see the sugar is being distributed uniformly throughout the water. So that basically is the rate of absorption, and it is uniform. But when we come to adsorption, the rate of adsorption, it is rapid in the beginning and reduces later. Okay, we can see when gas molecule is introduced into the liquid, okay, starting there will be a lot of gas molecules which tries and comes and accumulates on the surface. But after that, since the surface area will be reduced, the surface phenomena also reduces, as in the adsorption also will be reducing slowly. Okay, that is why we are telling here this adsorption process is really rapid in the starting, but it gradually decreases later. Absorption is independent of surface area. So absorption is not dependent on surface area at all. Okay, it doesn't require any kind of surface area or anything of that sort. It can take place without being dependent on the surface area. Whereas our adsorption, as the name tells, is a surface phenomena. So obviously we can see it is dependent on the surface area. If the surface area is more, the adsorption is actually more. If the surface area is less, we can see the adsorption process is less. So yeah, so that was exactly the differences between absorption and adsorption, right students? So I hope you have actually enjoyed today's class. It was quite we had a lot of other animations which were included. So I hope at least those animation remains in your head and you can understand with respect to animation more than my words, right? So with a lot of picture, you can remember a lot of things as well. So that is why we introduce a lot of animation here, which is going to be helpful for you all, and you all can relate and write your notes on your own just by seeing the animation. Okay, so in the next class, basically we will be seeing about we studied what exactly is adsorption, right? And the phenomena with respect to adsorption. So in next class, we will be seeing the different types of adsorption which are going to be taking place. There's physisorption as well as chemisorption. So what are the features of physisorption and chemisorption, as well as there is something called as adsorption isotherms. Okay, so what exactly is this adsorption isotherms? And there's specifically one isotherm in this adsorption isotherm, that also we will be studying in the next class. So as I told, I hope you have enjoyed this session. So we will meet in the next session. Until then, stay tuned to Vista's Learning, and in order to make sure that you get access to all our videos, not just in YouTube, or you can see all like the entire chapter videos, not just with respect to class 11 and 12, but with respect to any other subject in any other language, as well as different standards as well. You can see all of these in our website, okay, in our web application, which is www.v-learning.in. So here you can get access to all our videos, our academic videos. You'll have assessment questions as well as the study material available for the chapter. So I'll meet you all in the next class. Until then, stay tuned to Vista's Learning. Thank you.